Hey, welcome back. Today is February the 20th of 2024. Ethereum is kicking into the 3K. The roll-up space is getting so hot right now. The sentiment is getting better and better every day, and we are so back. I'm glad to have you back again. This is Developer Aligned. Let me show you something. It's white right now, but if I click right here, hmm, let me show you something. This is it. Okay. So we are so back, and this is developer aligned. Ooh, there you go. And there you go. Hi there. This is Developer Aligned, a series of live stream shows made for the contemporary open source Anon contributor. That's you. Hi there. Today we have a special show because, as I told you, each week we are trying to have a different show, and today's time is for the deep dive. A premium front row seat with the best talent of the Fuel team and Fuel ecosystem. So it's like a space to go into the realms of the technology. I know you like getting nerd, so today is the day. Before getting into the meat of this barbecue, I want to tell you what's next. We have a lot of stuff going on. We have ETH Denver coming nearby, and I want to show you this is the execution day. Oopsie, nobody saw that, right? Let me show you. This is it. Okay, so as you might know, as I told you last week, we are doing a lot of stuff during ETH Denver, and we are hosting the execution day. I'm adding the link right here, so you can enroll yourself and go and hang out with all of these people. We have Fuel, we have Risk Zero, we have Polygon Maiden, we have Movement Labs, we have Lumio, Cartesi, Aztec, and this is an event supported by Stratos, Immunify, so please don't miss this opportunity. But we have more stuff during ETH Denver, and this is we are having a special talk during the main event, and that's Nick, our CEO. He will be shouting a talk during the main conference of ETH Denver. I hope to see you there. But what else is happening? Well, we are having an ETH Denver special. Yep, just like that. For all of you that for some reason or another are not going to Denver, we have the ETH Denver special. So We will be having some reporters in place helping us to take a closer look on what's happening during ETH Denver. But there's more stuff happening right now. Let me show you. Fuel is getting better each time, and we have this is it. Who is this guy? You already know him. This is my buddy Ruben. We are hosting a Telegram channel so you or fuel pill developer can be and have the latest news of the ecosystem. Let me show you that link right here. Fuel channel is happening right now. So that's all on my side regarding announcements. So let's get to the main topic. Today's show is a deep dive with David, and today's topic is predicates. Yeah, finally, the mystery is being unveiled. What are predicates? Well, here we have David, and let me take you into the stage. There you are. Welcome back, David.
GM, sir. How you doing, Sandusky?
GM there. So, we're having a hot topic today. Like, I can remember previous shows, people just asking, like, hey, can we spoke about predicates? Like, people are getting so hyped about this all the time, and there's a lot of questions happening. Um, so, before getting into the hardcore stuff, David, how are you doing today?
I'm doing good. I'm having a good day. It's been beautiful here in Lisbon, and as you said, ETH's almost at ecosystems feeling good, markets are feeling good. Well, things are super exciting at Fuel, and I'm very excited for the next couple. So, yeah, everything is doing pretty well.
A lot of stuff is happening. Yeah. Um, I can say, I can announce that we are announcing stuff soon in the future. So please keep in touch. David, who are you? Tell us about you. Like, where you come from? Where are you doing? Do you even know how to code?
Yes, I have once or twice in my life. So yeah, for anyone, yeah, my name is David. I have been a developer in the Web3, blockchain, crypto, degenerate space for yeah, 4 or 5. Let's see, 2017. Oh man, that's been quite some time. 2017 kind of got crypto pilled and just fascinated with blockchain technology, learning how to build smart decentralized applications. And yeah, for the past few years have been building kind of worked with a lot of well-known projects with MakerDAO and Lido and stuff with the Ethereum Foundation. Some of you guys might know of a build called cryptofees.info, so kind of went down the data path. So yeah, just been very excited about the space in general and building all sorts of stuff. And yeah, I don't know if I should give you.
Well, I think many of us have seen crypto fees in the past. So thank you so much for your service. Um, Let me ask you really quick. Uh, how you got hyped about fuel? Like how you came into this ecosystem? Like what's the thing that keeps you up in the night when you think about fuel?
Yes, I've been part of Fuel since the very early, back in 2019. Nick, and was telling me about this crazy a way to scale Ethereum. He called me. He's like, David, we figured out how to fix Ethereum, and I was like, yeah, sure. It turns out that they actually had this idea of rollups, and then a bit later, when lockdowns happened, stuck stuck at home, just like everybody else. I was working with Nick and some of the early team members, and just kind of building really fun stuff on Fuel because it was clear that scalability problem for Ethereum. Since I got into Ethereum, that was around when CryptoKitties happened. There was like this really cool on-chain game that like took the whole network down. So everybody figured out how do we make Ethereum something that you know some fees are cheap, the transactions are fast, where we can things that are as cool as CryptoKitties or even cooler on it. And yeah, in the early days of Fuel, one thing we were working on a bunch was Reddit announced that they were doing their like community points program. Unfortunately, they program down a few months ago, but this was really cool. Like Reddit was getting into crypto. This was still before the last bull market, so there weren't that many like mainstream companies like Web3, and it was clear like they were not going to be able to build this points system, this community points thing they wanted to build on Ethereum. And so, me and Nick and Sam, we were like, let's build it on Fuel. We built like a demo of an app that could make Reddit community points, and it could bridge it into the Fuel testnet chain at the time, the Fuel V1 testnet, and just trying to kind of show off like this is like a really cool way to scale Ethereum. This is a way that you can build applications like what Reddit was trying to build, where this was not DeFi. This was not like this was just trying to build like communities using on-chain points and things like that. So we built that kind of demo, and at that time this was solving the main problem that needed to be solved, which was just scale. And since that time, I think that the space has evolved so much. Um, Scale is still super important, but there's you know Fuel as well as many other projects are kind of figuring out how to scale blockchains, and there's more and more problems that are rising as well. Things around user security, interoperability, things like that. So that's what really excites me about Fuel. It's that it's because we have this new stack, this new operating system built from the ground up. We can address like all these major issues that plague blockchains. Back then it was mainly performance, and now there's kind of so much more. But we can kind of go after this.
Well, I think we can agree that blockchain is way funner when we go beyond like internet money and stuff. And I'm so bullish right now into like Web3 social stuff. So I think it's so funny that you just got this history about Reddit. Because it feels like right now, finally, Web3 social is coming into space. Um, so yeah, thank you so much for giving us that context. I think it's really important to know that Fuel was the first optimistic roll up, as you said. So it's been like a long path since we were like trying just to mimic the EVM, like just taking the EVM into a faster iteration time. So I would love to start this conversation by introducing one concept, which is like um, kind of flag, like kind of the soul of this new stage of the Fuel and Fuel VM, which is what the fudge is an UTXO.
That's a great question, and UTXOs are interesting. Terrible. It's a terrible name. It's not using, and it's an idea that is quite simple. In fact, Bitcoin, the first blockchain, was built around UTXOs. Since that time, most blockchains don't use UTXOs, but Fuel is kind of one of the few that are. And I think there's actually going to be a UTXOs because there's some really nice properties, but is a UTXO. I think the best way to, well, I'll say a UTXO stands transaction output. So again, doesn't really clarify all that much. So I think the best way to think about a UTXOs are a little bit more like cash. It's whereas most blockchains, which use an account model, we've got a really nice diagram there. They're kind of more like a bank account. So think about when you do like a bank transfer or you do like a credit card transaction or something like that. Somewhere there's like one big database. If I send you some money, Sandusky, like my bank is gonna like look at my account and say like I'm gonna send you $10. It's gonna say, does David have $10? If so, we're gonna decrease his $10, and if Sandusky has $10, we're gonna increase his $10, and it's really hard to scale. It's hard to build things on top of because we want to build a world where there's tons of money like flowing around all the time, and we want to build a world where money moves much faster than it does in bank account. And the clearest example of a place where this money does move much faster and much more freely is the physical world with cash. If I go to a store, I hand them a $10 bill. They don't need to check in any database somewhere. They don't need to anybody, like they don't care about anybody else's transaction, how much money is in my bank account. They just know I handed them $10, and maybe my coffee, I'm buying a coffee and it was $4, and they give me $6 back or something like that. So that's kind of how, and UTXOs are kind of like the digital version of that. Every time you send some money, you're not just updating like rows in a database. You're like spending a coin and you're creating new coins. So if I'm just, if I have $10 and I'm sending you $10, then it's destroying my $10 and it's creating a new $10 in your wallet. And if I'm sending you $5, then it's gonna make a new $5 in your wallet and it's gonna give $5 back to me. So that's like at a high level what a UTXO is. Again, this is how Bitcoin works. It's how fuel works. And as we go into talking about predicates, we're going to see that when you combine this idea of a predicate and a UTXO, you have like a completely different way of building really cool properties.
It's been like a big issue, as you say, like having this big source of truth, like trying to build some kind of decentralized global computer by relying on this big spreadsheet. It's so funny because I don't know, thinking in Microsoft Excel is way more performative than what we actually have on Ethereum, which is like all of this Merkle tree stuff. So yeah, it's so exciting to start talking about UTXO because it's, as you said, it's the cash. Like we are trying to fight banks. Okay, this is the digital cash, like the true digital cash, and I can understand why Bitcoin choose this approach, where you have like these atomic pieces of a state. So you start having like some pretty crazy powers when you have like this atomic state. That's why I would love to get into the next step, which is why should I care about predicates? Like we already know we have like this fancy buzzword, which is UTXO, which is coming later back into the main topic. But why should I care about predicates?
Sure. So yeah, in terms of why you should care about predicates, again, predicates is a weird idea to wrap your head around. It's something that doesn't exist on most other blockchains, although they're actually something that's very similar to predicates on Bitcoin. The I guess to give like a quick history on the history of blockchains is we started with Bitcoin, this blockchain that's super simple. It's just coins. There's some form of scripting and interoperability, but it's not interoperability. Some form of scripting of customization, but it's really basic. But it captured a lot of people's minds about what we can do with blockchain technology. So then we kind of went to the other direction with things like Ethereum and Solana, all these new blockchains where you can do everything with them. You can make a smart contract that does everything. But what we do with a predicate is a piece of code. It's basically like a super powered account that's can do most of the things, basically everything that a smart contract can do, but it can actually do a little bit less. But by just being a account that's got special properties, it makes it more efficient, more performant. It's like a bit more lighter weight than like a smart contract, and it lets you do some interesting things you can't normally do with a smart contract. Like a predicate can pay gas fees. A predicate can own assets in a way that smart contracts can't. So the main reason I'd say that you would care about predicates is because you can build different types of application with predicates than you can with normal smart contracts. So they're cheaper, and they can do kind of different types of things. And yeah, I'd love to kind of go deeper into predicates, but let me know what you think about that.
I know for sure this is a topic you love. Actually, there's presentation you made a few months ago that was Sway Summer, which was like one of these online Sway hackathons, and you said something really good back then, which was like predicates are like code owned assets. So it's like having the possibility to have code to decide whether an asset should be spent or not. Um, and as you said, it's really hard sometimes for many people to grasp around the concept of predicates because it's not something common. Like it's not something everyone is trying to do. For me, it's like bleeding edge technology. And when something comes as brand new, um, it's hard to like get your head around. Like this week, I was watching a really funny video on BBC about like sending an email in 1986, and was like so funny because they were all the time saying like, oh, this is so simple, this is extremely simple, but was like so crazy because they had to like um plug the telephone cable into the computer and then do a real call to the computer just to establish like the handshake. So that's like so funny. So it's okay if some of you in the audience feel like things get complicated. That's how it feels to be in the bleeding edge of technology. So it seems to me like it's a good moment to start like getting a little bit deeper into this concept of predicates. Um, I was sharing this piece of information, which is coming from the official Fuel Network documentation. Let me share the link right here. Um, so they say, from the perspective of Sway, predicates are programs that returns a Boolean value and which represent ownership of some resource upon execution to true. They have no access to contract storage. And here's a trivial predicate, which always evaluates to true. So we have like the standard program definition of Sway, which in this case is a predicate. And then we have a function that returns a Boolean, like what is this? Like what's happening here? Where is this being executed? What's happening after the evaluation of the Boolean results in true? Like, can you give us some context on what's going on here?
Sure, sure. So yeah, I think the best way to, as I said, like a good way to think of predicates is predicates are like programmable wallets. It's a type of wallet. By default, when you're using a wallet, if I'm sending a transaction, there's rules about like, is my transaction valid or not? The basic rule is like, did I sign a transaction with my private key? So when you send, you send a assets are in an address. That address is basically your public key, and so I'll send a transaction, and the blockchain will say like, is there a signature on it, and is this signature signed by the person who owns these assets? What a predicate lets you do is it lets you change that logic. So it's not just like logic being like a simple like let's check a signature. you can have logic that's even more simple. So you showed this example here, like a predicate that returns true. This is basically like a wallet. So you can like send tokens to this predicate that's always going to return true, and then anybody can like send a transaction from this like this account and just take all the probably not super useful, but like one thing I said is that like in my presentations, there's no way to actually do this easily on Ethereum. You'd have to make like a smart contract, and someone would have to like pay gas to like if you just want to just give away tokens. So in Fuel, you could just make a simple predicate like this. But things get more interesting when you obviously add more interesting logic. So one of the most common ways predicates are used is as a form of account abstraction. So account some of the idea of account abstraction is changing the logic of how a wallet works. So for example, like a normal Fuel wallet is like a unique type of wallet. We have there's like a Fuel Chrome extension wallet, and there's a project called Fuelit that's building an awesome wallet. But let's say you want to use a different type of wallet. Say you want to use MetaMask. Everybody's got a MetaMask, right? We've built a predicate that says it'll when you send a transaction, it will check a MetaMask signature or any EVM Ethereum wallet signature. So now we've created a new type of wallet using predicates. You can do the same thing with SUI wallets, like any type of wallet. You can build a new type of account, or maybe you want to do a multi-signature wallet. You could make a predicate that says instead of checking like one signature, this predicate's going to say like, okay, I'm going to check 3 different signatures, or I'm going to check like 3 out of 5 signatures are valid. So you code whatever logic you want the predicate, and now you make like some customizable wallet that does like all sorts of interesting stuff. So that's kind of like, I'd say, the most common way that predicates are used, which is account abstraction. But you can do other things with predicates too. You can do applications with them. So we have some of the projects on Fuel are building order books with predicates. So imagine like, what is an order book? An order book is just a bunch of orders, and every order saying like, I will give you asset A for asset B at a certain ratio. So I'll give you 1 ether for 3,000. And you can make a predicate that says like, you can kind of put 1 ether in a predicate and set the rules of that predicate to be anybody can take this ether as long as they give me 3,000 USDC. So that's like you can just do this atomic swap, and it's super lightweight, right? You don't need to deploy a smart contract to do this. You don't need to, what we'd say is like write to the price and everything like that. You just kind of make like a really kit that can kind of perform that action. You can do type of application is you can use this for like sponsored a demo. Hopefully it should be done soon, of like an NFT project where you can mint an NFT, and for the user the mint is free. That basically, like, say you're an NFT project and you want to cover users' gas fees, you can make a predicate that will let them mint the NFT for free as long as they're minting an NFT. Or you can have types of whitelisting. You can do really interesting things. But those are kind of like just a few examples of what you can build with the predicate. But I mean, the thing I'm most excited about is like seeing what ideas people come up with for predicates. Like the NFT thing was like an idea that I came up with. The order book is an idea someone else came up with. But like as more people learn about predicates, like I think there's going to be like really new ideas, like new applications that just can't be built with the blockchains that'll be built with.
Well, it seems like it's like a rabbit hole, like as soon as you have this feature of having like these programmable smart wallets, you might say, um, sky's sky's the limit. But I want to like do a small step before getting into the NFTs idea, because I have your GitHub here on my tray. We will take a look into that code later. So feel free to blame David in the comments. It's just joke. Um, Yeah, laser. The we are getting the code on a stage pretty soon. But um, when I was taking a look at the definition included in the SWAY documentation, they say something like they can't access the contract's state. So you said like they can do almost everything like smart contracts, but they are not smart contracts, but smart wallets or programmable wallet. But they can access the state. Like how does this works? Like um, how does this relate to the UTXO concept? And how is this stateless or maybe a state minimized?
Yes, that's a great question. So, as you're saying, predicates are in many ways like a bit more limited than contracts. Like they kind of look like smart. You write this code, you write it in Sway, our programming language, but they can't do everything a smart contract can do. So, as you said, predicate can't like call another smart contract to look at its data. What a predicate does is it checks if a transaction is valid. It doesn't check like it doesn't run the transaction. It just kind of can look at the transaction itself. So it says like, you know, who did the transaction come from? What is the transaction trying to do? Again, not what is it not is it doing it successfully, but what is the transaction trying to do? What assets are being included as inputs and outputs? So, you know, this is something specific to Fuel because assets are native on Fuel and because Fuel has these UTXOs attached to transactions. You can look at which UTXOs are attached. So it can look at kind of like what the user's trying to do and approve the transaction based on that, but it can't access state, as we would say. And this is what makes predicates, as we'd say, stateless, and it's what makes them so much more efficient, so much more lighter weight. So as I said at the beginning, like even if you're building something with a predicate where you could build the exact same thing with a smart contract, it's going to be much cheaper and much lighter because of the way like predicates are processed. They're a bit more limited. It makes them just much cheaper. You know, the code is not stored on chain. That it doesn't read state, so it's super lightweight. So you can't access like the current state. You can't look at like what is the balance of an AMM or something like that, or you know what's the current. I'm trying to think of a good example. You can't call another smart contract, but you can look at the inputs and the outputs of a transaction. So you can look at you know which tokens did a user include in a transaction. So without going into too much detail, you can kind of attach some form of state in some sense just by creating assets that represent state. This is an idea I've called like packets. You're basically like taking a bunch of data from a chain and like putting it into a UTXO, and then the fact that that UTXO exists represents a bit of state. So an example of this could be that NFT minting application I mentioned. For you know, if you're going to pay for um, if you're going to pay for a user's transaction fees, there's like potential for a user to start like spamming the network, right? Because their fees are free. Yeah, here's the code here. So I wanted the ability to whitelist it because if you don't whitelist it, again, someone's just going to like spend all the ETH for gas fees. And the way that we made the whitelist is instead of having a smart contract that tracks the whitelist, that's how you would do it on most blockchains. For this one, we would mint a token. You can think of it like an NFT itself, but it's not like an NFT that you would trade. It's just an NFT that represents like this user is on the whitelist. And now when I send a transaction, I'm going to include that that packet, that NFT, whatever you want to call it, in the transaction. My predicate can look at it and go like, well, this token exists, and it's got like the user's address in the token, so therefore the user's whitelisted, and I'll pay for his gas fees. And if I'm a user and I start like spamming the network and like taking advantage of this gasless application, then someone can just like burn that NFT, burn that packet, and they've removed me from the whitelist. So that's a really simple example of how you can have some form of state that a predicate can access, but you have to kind of like attach state. You have to put it in a UTXO itself. So sorry if that was like a little bit like technical in the weeds. This is, as we said, like a new idea. This is something you can't really do in with smart contracts with most other types of blockchains. So yeah, we're still, I think, kind of figuring out like what you can do with it, and also like how to best explain it.
Well, we promised a deep dive, so I'm glad we are getting the deep down in the loop. And I hope like this conversation helps people like to trigger their curiosity and start like digging around these concepts, trying to understand what's happening and how is so powerful, how predicates can like actually allow parallel transactions, which is a huge topic. Um, I think you hit a really important point, which is studying code into the blockchain, because the state load is becoming a big issue right now in the space. Um, we do really care about decentralization because of security and so on, and studying so much crappy information in the blockchain is making so hard to run a node. So it's so easy to spam a blockchain with just random code and stuff like that. So it's so powerful that um, having a stateless execution, like having these programmable wallets, like having the code to be maybe a seed phrase for some kind of wallet, um, it's like so powerful. We have crypto. Like, do you answer questions from chat? We do. You miss your opportunity, but try again, please. Um, we have also Dylan asking, are the assets immutable or can they be removed from the chain state? I think this is a really good question because um, you can track an asset balance on the chain by using UTXO, but you are not having a big spreadsheet of balances. Uh, and then you can like decide whether these assets can be spent or not by using these off-chain predicates. So like, what's happening here? Like, can you take a word on this, please, David?
Sure, sure. So yeah, I'd say assets on Fuel, they're just as immutable as any other blockchain. So if you have an asset in your wallet, that's your asset. That's you own it. There's not really, in fact, I'd say in some sense they're more immutable because Fuel has these native assets. So there's not really an ability to like build custom logic into those assets. So the assets in your wallet, it's in your wallet. So the only way to remove an asset from the chain state is if you send that asset, if you transfer it or you burn it or something like that.
Which is funny because like it's not being removed, it's like becoming out of reach.
It's becoming spent.
Yeah, it's becoming spent. So let's get one step further down in the loop in this rabbit hole, and let's come back to this fuel NFTs. So it says like this repo is an example application built for Fuel, which allow users to mint and transfer NFTs without needing to pay any gas fees. This allows users to use applications without needing to first purchase ETH on an exchange, on Ramp, etc. This application allows a third party sponsor these transactions by putting some ETH in a predicate that enforces the condition by which it can be used in a transaction. So then it comes like the white listening, some technical components for those who want to like follow up this repo. Please visit github.com/dmihal slash fuel dash gasless dash NFTs. Um, David, I remember back in the days you mentioned earlier on in the streaming, CryptoKitties and the NFT will run and the network collapsing around funny profile pictures. But I remember back in the days, OpenSea having like this some kind of proxy contract where they were paying the gas for you. Like they were doing some kind of gasless NFTs. Like you still had you still need some kind of ETH to start like the whole call, but the minting gas was paid by OpenSea. Um, how is this different from that? Like because that like having gasless NFTs is kind of possible by using smart contracts on Ethereum, but this seems like kind of different. Like what's going on here?
Totally. So that idea, I think that's what I think people still call it this. On Ethereum, we talk about meta transactions, and the idea there was to do things that are gasless. Instead of signing a transaction itself, you can sign just a message, and there's like a smart contract that will validate that message. So if you have a smart contract wallet on Ethereum, you can sign a message saying, "I want to send a transaction," and instead of sending, when you send a transaction, you send it to the mempool. You basically send it directly to the blockchain. So instead, you would sign like an off-chain message, and you would give it to somebody else that'll pay the gas fee for you. You just give them the signature, and they'll package it in a transaction, and they'll send the transaction to the blockchain. And that's how, that's how meta transactions work. That's how a lot of these like gasless NFT things work on Ethereum. It's how a lot of the account abstraction, like EIP 4337 in Ethereum, works in a similar way. And again, there's been a lot of like progression there, but it's still like somewhat of a workaround, right? Like if I have a smart contract wallet on Ethereum and it has Ether and I want to send a transaction, pay ETH, why do I have to like go, like I have ETH, it's in my smart contract wallet. Why do I have to get somebody else to pay my gas fee in ETH and then when I already have ETH there? So with predicates, we kind of like, we get rid of the need for this workaround. If I have a predicate wallet and it has ETH in it, it can just pay the fee because a predicate, it is an account. Ethereum, like someone always has to send a transaction and pay the transaction fee from their wallet. So that's why we have this kind of workaround. With Fuel, you can say like, we've got this super wallet. And so, the super wallet can pay the fee, but it can still have like this special code, the special logic. And so doing it again, things get easier. You don't need this like kind of workaround to do like account abstraction. And because we've removed this extra like workaround stuff, the transaction just gets cheaper, right? Like you don't need like to validate a relayer signature. You don't need like somebody else paying the gas fee and stuff like that. You remove a lot of the complexity, and that makes it easier for the developer, easier for the user, and it just makes it easier for the chain itself. So then the fees go down. So just a lot of benefits across the board.
It feels like a killer feature because right now it's so hard to onboard users to crypto. I always think in this new narrative from the Ethereum Foundation, which is like the next billion. And it seems like so funny that I need to make my users pay just to try my service. So I'm glad we have like this mindset of actually making gasless stuff, like allowing contracts to sponsor the transaction for the users, because that's the right way to like onboard a billion people into blockchain. Right now, we are having like so much hype with these ETF approvals and so on. So like, there's people talking about having the big retail getting into crypto. Most of them will be like just buying, but sooner or later they will be like interacting with applications. And it's so sad that you go to these people and tell them like, okay, you're having so much fun holding your assets, maybe staking your assets, now please spend them just trying my application. So it's like a nonsense in some ways. um I would love to have maybe a quick walkthrough on what's happening here, because like we can try to settle our minds around um, how a predicate work. We can like agree on these programmable wallets, these smart wallets, these code owned assets, but how they are being executed, like where's the beginning here in this file system? Like which file should I open?
Let's take a look. I mean, I guess the place we could start would be the NFT itself. So the folder that just says NFT, because this is what we're ultimately trying to do in this project is let a user mint an NFT. And so this is the smart contract for the NFT. I like this because it's really simple. If we're making a simple token here, there's not that much code here. So we have a mint function. This is the main thing, and it's basically checking like how many you can only mint like max supply. So whatever the max supply is, 10,000 NFTs. It's mostly
Yeah.
just checking that. The rest of the code is pretty simple. We have like a bit of metadata here. If you compare the number of lines of code, especially get rid of the comments, like the number of lines of actual code here against an NFT in Solidity, it's really short. It's really like lightweight because again, assets are native on Fuel. So to mint a token, you need like you just need. Um, so yeah, we're just kind of like most of the code we're doing here is like metadata. We're just saying like what's the name of the token, like what's the
Yeah.
decimals, things like that. So
And
very
it seems like
simple.
Sway is like such a lightweight language. Like the syntax is so clear that I don't know. I think anyone who already tried Solidity for a while can actually like understand what's happening here. So okay,
Yeah.
that's an NFT.
The NFT, super
Let's go back.
simple. There's just like a mint function. That's the only thing we care about. It's like we want
Yeah,
users to call mint so they can mint an NFT. The
just
next thing
minting
would be
stuff.
this.
Okay, I want
Yeah,
to hold for a second.
sure, sure.
Aburlidius is asking, can we speculate on how predicates might be used in prediction markets?
Interesting question. The main thing I think of is prediction markets. They're a type of market, right? They're something you trade, but instead of trading like ether or stable coins, you're trading this like token be worth like $1 or $0 depending on if something comes true. And uh, order book exchanges are really useful for trading things. They're very capital efficient. Like most of the world runs on order books. There are like a lot of reasons that AMMs like Uniswap are also good, but I think especially for prediction markets, which tend to not have a lot of liquidity, like order books work really well. We've seen prediction markets have been a lot more successful on order book exchanges than on like Uniswap style AMMs. And as I said before, like you can build a really lightweight order book with predicates. It's like the cheapest way to build an order book on a blockchain is a predicate because the way you would like open an order is you just move an asset you just send an asset from your wallet to a predicate. You don't need to like touch smart contracts. You don't need to like store a bunch of data. It's just like a really lightweight asset transfer. So because Fuel is such a good, you know, because Fuel has UTXOs and predicates, and that makes it a really good platform for building order books. I think that in turn would make it a really great platform for building prediction markets. So, as far as I know, I don't think anyone's building prediction markets on Fuel yet, but that's actually like would be a really cool project to see. So if there's any devs here that are looking for a
Wow.
project, maybe that was a good idea here.
We have a grantee program. Let's keep in touch. Follow us on Twitter. You might have some good news pretty soon. Yeah, your ideas are welcome. Like if you feel you want to build something, just come and say hello. Mem Crypto is asking like, oh, Phil is really early. Um, yeah, sounds like a good grand project. Yeah. Thank you, Agor, and please come by and build.
Thank thank you for the
Um,
question.
Thank you for the question, indeed. So, Mem Crypto is asking, do I understand correctly that Fuel is at a very early stage and is not going to enter in the mainnet quite soon? Um, well, I don't know how to say early because Fuel V1 is actually live as an optimistic roll up. We have been building like for 3 years now, so we have like this amazing and mature language as we were showcasing. We have like this really nice and mature VM. But I just want to pick up a comment from earlier in the streaming, which is um, this one regarding mainnet. I can say that we are announcing stuff in the near future. So regarding your specific question, Mem Crypto, if we are going mainnet, just keep in touch. Maybe you get a surprise later.
As
Okay,
I said in the
let's.
beginning, exciting
Yeah,
things are happening in fuel. It's a good time
I'm
to be in
excited.
fuel, and I think that's all.
Well,
Okay, we can.
Looks like Ruben is spilling the beans, so it's happening. Yeah. Okay. Let's go back to the gasless NFTs. We were just looking at plain NFT, pretty basic stuff, just minting an NFT under a max supply. What's next?
Let's go to the NFT script. So we haven't talked
Okay.
about scripts much. On Fuel, we've got there's kind of three different types of code you can make. You can make smart contracts. Everyone knows what a smart contract is. It's code that's stored on the blockchain. And now we've been talking about predicates, and predicates are these like super accounts. So they're accounts that have special code, and they kind of say like, is your transaction valid or not? And then the third one is a script, and a script is like the code of the transaction itself. It says what that transaction is trying to do. You can think of on Ethereum or the EVM, a transaction can only do one thing. It can call one function. That's all it can do. Or the other thing it can do is deploy a smart contract. But for the most part, you can just call one function. There are some other blockchains where you can call multiple functions. So you can say like, okay, here's three different functions I want to call. In Fuel, you provide a script, and you can do whatever you want in that script. So you can call one function, you can call multiple functions, you can calculate the square root of pi and just return it. You probably don't want to do that. You can move a bunch of assets around. So this is just like the code that runs during the transaction, and then it never runs again. This is really useful for like if anybody like is familiar with the Uniswap code base. Swap has like a router contract, and this contract again, it's something that really should be a script if it was on Fuel, but Ethereum doesn't have scripts. This is a smart contract that just says like, if I'm swapping on Uniswap and I want to swap through pool A, then I want to swap through pool B, and then I want to make sure that that I didn't have too much slippage, that I'm actually going to get enough tokens out as I wanted to. The router is the contract that like does that code. But on Fuel, like instead of putting that in a smart contract, because again, smart contracts they're kind of expensive. You have to store the code on chain. They're designed for this like kind of shared global state. If you just have something that's like kind of saying what the transaction should be doing, it should just be a script instead of a smart contract. So that's what you can build with the script. So here we're building a script that this script just, for the most part, it just mints an NFT. You can see there's also like a packet, there's that if statement at the bottom, but let's kind of ignore that for now. I'm going to, in the interest of like keeping things simple, let's ignore this packet minting. Line 12 and line 13, we're just like calling the NFT smart contract and we're minting an NFT. So this script is pretty simple. It's a script that only can mint an NFT. The reason, and again, in many cases, you wouldn't need to like write a whole script to do this. You can just like call a smart contract like you would on Ethereum. But we made a script because what we want to do is we're going to make a predicate that only lets you use this script. The predicate's going to check, is this the script that's like attached to a transaction? And if it is, it'll pay your gas fees. And if you have a different script, if you're doing something other than like minting an NFT, then it says, I'm not going to pay for you to do something else. I'm not going to pay for you to kind of like call other contracts or whatever. So that's the script.
So it's like we are verifying the behavior that the user is going to perform by using the predicate.
Exactly.
It's like
We're
the
saying
power
this is
of cryptography.
exactly, yeah, and we can make this really like simple and lightweight. So now let's jump over the predicate, and I'm going to warn you, this predicate is it's long, it's complicated. So this would be the gas predicate. So what this gas predicate is, let me explain like what this would be used for. This is where, if I'm the project that's making this NFT and I want to pay for users' transactions, I'm going to put a bunch of ETH in this gas predicate. So I'm basically saying like, this is how much ETH I'm willing to pay for people to mint an NFT. And I just send that ETH to this predicate, and now anybody can spend that ETH as long as they as long as they're doing like meeting the conditions that I'm setting. And so that's what this predicate does, is it sets those conditions. And again, the conditions are kind of complex. As we scroll down, we'll see there's a lot of code here, and I'll explain some of it. But okay, so that first section here, is script valid? There's a little
Let me
bit of
just
like
press the dot here so we can get like VS Code experience. Is that possible?
the VS Code experience.
Yeah, I remember that you can just like just go into VS
There
Code from
is
GitHub.
some way to do it. I don't
I
remember
think
how.
you have to be
If
logged in. Let me try because I want to have like better highlighting. Yeah. Oh, code spaces. Oh no. Oh, web editor. Yeah, it's happening. Okay, let me just
okay,
remove this, stop this, close this, choose this one, and go to. Oh, it's loading. Yeah.
here we go.
Okay.
I was gonna say I need to clean up this code a bit. I saw like the first bit of code. There's like a weird the way the if statement is kind of. Don't touch my code. There was a reason, and we're gonna fix it.
It's like when you come to the office back on Monday and you say like, "Who wrote this?" Oh, was me. Yeah.
Yeah. We don't have highlighting though.
Um.
I think the
Oh,
highlighting was better on GitHub. Yeah, because it doesn't have
yeah.
the extension.
Well, let's go back. Let
Oh,
me
that's how
check.
you do. You just github.com, github.dev. Okay, that's cool.
Yeah, it's
Cool.
amazing,
Well,
right?
we'll have that sorted for the next one. But yeah, for now, let's just take a peek into this. So as we were looking at the beginning, the first thing it's going to do is check the script. Um, on line 40, 43, and 44, that's like the meat of it. So the last code we were looking at before was the script. Um, and so what we're going to do is we're going to get the hash of that script. And we don't even need to hash it ourselves. There's like a function we just call script bytecode hash. Um, and that function is it's going to give us the hash, and we're going to check, is that the hash we're expecting? Is that the hash of the script that we wrote before?
So this is a constant, right?
Yeah, that's a constant.
Okay.
So if it's not, then we're going to return false. Again, ignore the weird logic there. We'll clean that up. So the first thing is like, are they using the script that we wrote before? If so, awesome. The next thing we're going to check. So basically, there's two ways. I mentioned before, like there's kind of a whitelist of who can mint NFTs, because if there's no whitelist, then someone can just like burn all your gas. Maybe that's okay for some projects, but for this one, we wanted to like have a whitelist. The two ways you can be on the whitelist, one is you would like ask a server. You'd go to a centralized server and say like, this is my address. I want to like mint an NFT here, and they would give you a signature. They would like sign your transaction, and you attach that signature to the transaction. So then that's actually towards the bottom. Why don't we jump down to the bottom? Let's see. Here we go. Signature index. So yeah, if there's a signature, we're just going to check like, does that signer match? Did the person who made the NFT project sign this transaction? And if they did, if they didn't, we're going to return false. The other way that you could be on the whitelist is with like the packet that I mentioned. So basically, like the idea was that you don't want to like have to ask for a signature every time. The goal of this was not just to be able to mint NFTs. It was also to be able to like transfer NFTs, trade NFTs, things like that, and to do that all gas free. So you don't want to like need to rely on a centralized server. So the idea was like that centralized server can like mint this NFT, mint this packet that whitelists you, and then all your transactions are essentially like sponsored. And if you start spamming, like maybe they'll detect it and they'll kind of like burn that asset. But that's the unhappy case. So that's like that
I'm
second
looking
if block
something
there.
weird, and I'm going to hold you for a second because
Sure.
what's happening? Like, why are you using elliptic curve stuff? Like, is this a helper you wrote? Is this built in the language?
That's built in the language. So that's the we've nerd sniped Ruben. That's the function that lets you validate a signature predicted by a elliptic curve signature. There's a few different functions for different types of signatures, but this is like the default type of signature. So we're just checking like, did the NFT creator sign this message? Did they actually sign this signature?
Well, it seems amazing. Like you can just mess with cryptography so easily by using a standard library. So yeah,
Yeah,
please go on.
yeah, sure. So that second kind of if block there, starting with like this unknown asset thing, this is like looking for the packet. And again, like the code gets a little messier, a little harder to decipher, but this part here, as well as some of the code that we skipped over, we're basically checking all the inputs and the outputs action. And what we're trying to do is we're trying to say like, um, there's basically like a set of rules for this transaction. So some of the rules is like the only assets you can include in a transaction would be ether, because you need you can spend ether from this predicate to pay your gas fee. You can move NFTs around, so you can have like the NFT that's part of this collection that can be like the input and the output. So I can just transfer an NFT from to you Sandusky, and this predicate will pay for it. And the other type of asset that can be included is this packet. So there's logic to kind of like check out those packets and kind of like decode those packets. The other like bit of complexity here is you kind of have to like do some hashing to check like where did the asset, like you're basically checking like which type of NFT is this. So if the NFT comes from like this specific NFT collection, we need to validate that. The other thing we're validating is which smart contracts can be included, because you only want to include like the specific smart contracts that are like the NFT smart contract. So that's like the majority of the logic here is like checking the inputs, checking the outputs, making sure the user can't like add anything extra. The user can't like, they can't transfer the NFT and like a bunch of USDC at the same time. Like they're limited in what they can do. If you want to do something else, you're welcome to do it, but you got to pay your own gas fees to do that.
So it's like we are just filtering out all of the transactions we want to avoid regarding this gasless NFT. So we can just keep on the transactions that are going to interact with our NFT. So, doing a quick recap, we went for an NFT, we deployed that NFT, and we attached this script, this minting of the NFT to the transaction. And then we have a predicate, a gas predicate, that is checking whether whether you are using the right script, and then it's filtering out any kind of transaction that is not specifically the NFT transaction, right?
Exactly.
Well, people is already hyping like gasless NFTs. This was an amazing development. I agree. Like as I told you before, this is a killer feature for the next billion, as the EF is pushing. So yeah, we already went to some of this code. Um, what's going up next? We have a packet minter. We have a packet predicate. Um, you gave us some information about packets, which is basically this kind of marriage between a signature and a transaction request. Um, where should we go next?
Yeah, let's take a look at the packet minter. So I'd say the way I describe a packet is it's like it's a UTXO, or you can even think of it as an NFT, but it's an NFT that includes data in it instead of including, like it's not like an NFT that's got like a picture attached to it, or it's not an NFT that you would trade. It's an NFT that's just like kind of, in some sense storing data on chain. So what this packet is, this packet's used for the whitelist. So if you scroll down and look at the code here, this is the smart contract that would mint that packet. Insured transaction signed. Let's see. There should be a function called a mint. I'm looking for where this. Oh, okay. Mint packet. Simple. So what this is doing is the idea here was that the creator of the NFT collection can mint a packet, they can let a user mint a packet that will like whitelist them. So all this function is going to do is first it's going to check the signature. It's going to check like did the administrator sign the transaction, and then it's just going to mint a token. But you can see it says subject. The subject, we're basically taking the user's address and we're putting it into the asset ID of the NFT itself. We're in some sense like storing the user's address in the NFT. It's actually hashed. It's not like totally readable, but we're like hashing the user's address and putting it in a NFT. And we're not giving the NFT to the user. We're giving it to this packet predicate. You can see there's like a packet predicate address there. So maybe we go look at that packet predicate, because the whole purpose of this is we're going to mint a token and we're going to let anybody include that token in their transaction, but they can't spend the token. They can't like transfer it to somebody else. All they can do with this NFT is they can just it's almost like a read-only asset. Like I can look and I can see that asset's there, but I can't spend it. I can't take it or anything. So this predicate here, this is the predicate we give that packet to, and what it's going to do, it's just going to check that if you're going to include a packet, you also have to leave it there. So again, I'd have to look through the code here again, but it's going to...
Okay, but I think a good question just came by me and Goran, and it's how the transaction can go through is there's no gas involved, and I think it's a great question because make us go through the topic of how predicate evaluation works. So it's
That's a
like
great...
the predicate is just like a wallet, right?
Yep.
And it's a wallet that behaves regarding some kind of code. So we are trying to build a predicate, which is a wallet that can use its own funds in behalf of another user transaction. So this is happening on the client, the node itself, and it's using the powers of cryptography to check whether the transaction is valid, the script, which is the program we are trying to execute, is valid. It's checking whether the transaction is just an NFT transaction, an NFT minting in this case. David, how is that the transaction can go through if there's no gas involved?
Great question. So one thing to clarify is there is still gas. There's no transaction on any blockchain that doesn't have any gas, because blockchains, they're resource constrained environments. There's limits to what you can do with them. So you need to kind of pay for those resources and avoid spam. So when there's gas, either the user's paying for the gas or somebody else is paying the gas on the user's behalf. So what we're building here doesn't get rid of gas. It just lets somebody else pay those gas fees, and it makes it kind of like really easy to do that. So the way that the way a transaction gets processed on any blockchain, one of the first things that the node does when it's checking is this a valid transaction is it checks is there gas to pay for this transaction. If there's no gas, you want to throw it away, and you want to do this as like the first thing you do, because say I make a trade on Uniswap and my transaction fails, I'm still going to pay gas for it. Like you're always going to a transaction can like do a lot of processing and it can fail, but you still need to pay for those resources. However, if there's no gas in the first place to pay for, then like you don't want to waste any time looking at that transaction longer than you need to. So this really needs to be the first thing you check. And that's why on Ethereum or on most blockchains, the first thing it does is it looks at who sent the transaction and can they, pay these gas fees. On Fuel, because we have predicates and because these predicates can pay gas fees, because again, predicates are just special accounts, when it's going to like evaluate, before it like runs any code, before it mints any NFTs or swaps on Uniswap or anything, before it does like the real kind of meat of the transaction, it's going to check, is there some ETH to pay gas? And on fuel, that ETH doesn't need to be in like a person's like, public key account. That ETH can be in a predicate. So it's gonna first check like, okay, here's some ETH in a predicate. Now it's gonna need to run that predicate, run the code of the predicate, and say like, is the predicate gonna let me spend this ETH? And it can run it, it can kind of evaluate it, and the nice thing about a predicate, if a predicate returns true, it'll always return true. That's why one thing we mentioned before is like predicates can't access state, they can't look at smart contracts. Um, if your predicate returns true within the context of the transaction that it's in, then it'll always return true. That means you'll always be able to spend the ETH that's in that transaction. So to kind of circle
So
back
it's
where,
like,
oh,
yeah,
go ahead.
it's like gasless NFTs is like marketing naming, but actually this is a sponsored gas NFTs.
Yes, from the user perspective, it is gasless. Someone's always paying gas, and the nice thing is, the more we can get gas fees really low, I think the more common it's going to be um, to sponsor user transactions because it stops being an economic problem, right? Like, why are transactions? Why is nobody paying for my Uniswap trade on Ethereum right now? It's like, well, it's pretty expensive. Actually, if there's any like here, they might remember Argent. There's a wallet called Argent that's still a great wallet, still around. But when it came out, the transactions were free. Like Argent would pay your transaction fees on Ethereum. It was amazing. Problem was that the fees went up, and it was really quickly that they said, okay, we can't. First, they said like we will only pay for token transfers, nothing else. Then they said we're not going to pay for your transaction fees anymore because Ethereum's really
Yeah.
expensive. But when fees get really low, then transaction fees are not really an economic problem anymore. They're just a user experience problem, right? Like, oh, like I need to pay 2 cents for this transaction, but I don't have 2 cents of ETH in my wallet. I only have other tokens. But once fees get down to a few cents, if they get lower than a few cents, be a lot more. There's going to be a lot of people who will say like, oh well, I'm happy to pay that fee, in order to get users using my application. And then you just want something like Fuel that's going to make it easy for developers to pay the users fees on their behalf. And again, that's why predicates are so cool and will be especially like useful when we get into this like really scalable future where blockchains are really cheap, and the fees are cheap and easy to use.
So it's like we have a wallet, Predicate, and this wallet is a code on wallet. It's like a wallet that behaves um, regarding some kind of code. Um, a user is trying to submit a transaction into the blockchain, and we are like um, willing to sponsor this transaction. So we have a predicate that is not only going to spend money on behalf of this user, but is also checking whether this transaction should be sponsored or no. So we don't waste our gas on spammy transactions and so on. It's something like that, right?
Yeah, exactly. It's saying I'm willing to pay for someone else's transaction, but I'm going to set the rules for what I pay for. So they can't do whatever they want. So they can mint an NFT, they can transfer NFTs, they can do some specific things, but I'm going to be in control of that.
Well, Ming is having an opinion here, which is I just want to clear that the gas less name might mislead the user to transact without having a fee. Um, well, I think this is a proof of concept. Like we can go down with the naming afterwards.
Yeah,
Um,
I think
yeah.
in the case of something like this, it's up to the NFT project to, they're the one that's paying the fee, so they're going to figure out how to market it, how to set the rules, how to set the expectations for their users. So, at Fuel, unfortunately, we're not paying your gas fees for everything. We're just giving the tools to developers to enable them to kind of fees for their users if they choose to.
Well, I think it's a space full of possibilities. As we begin this streaming, the world of space is getting so hot right now, and it's so refreshing that we have like this new technology, bleeding edge technology with new possibilities, prediction market based on off chain, crypto secure, parallel stateless execution. Like it's getting so hardcore. Like there's a lot of stuff we can do, and here we have this repo, which is fuel gasless NFT, just a proof of concept on how you might um, perform sponsored transactions for users regarding some specific use case. It's so amazing, like makes me so hyped. I would love to just take a look at this, a deeper look at this, and this is the invitation to all of you. Come to this repo, take a deeper look, go to the Sway documentation, start hanging around, go to our Discord, ask questions, just get involved. We have an amazing grantee program, so you may end up getting some funding for your amazing idea. David, I have to wrap it up. I have to be honest, we have somebody else in the queue. So thank you so much for sharing this amazing code with us. Um, Please come and give it another iteration, because some people say so your weird conditions, or maybe somebody else is willing to do that. This is open source. Feel free to come here and open a new pull request. I think David will be more than happy to take a look at your code as well. David, any final words regarding this amazing session we had today?
No, I think just it was a lot of fun. Thanks so much to us on, and very excited to see if people come up with cool ideas. Again, it sounds like we got one good idea for maybe a prediction market built with cool. I saw Ruben sounded like he had an idea as well, so would love to see cool ideas coming out of this. And thanks everybody for coming to hang out with us.
Well, thank you as well to me to of having like these great questions. Um, well, it's been a lovely session. A lot of code. Just before saying bye bye, actually bye bye, David. I'm taking you out of the stage.
Ciao.
Okay, so we are not done. We're still having one last surprise, and that's it, my buddy Hardik. You are on a stage now, so welcome abroad.
Hey, how are you doing? First of all, I don't know if David's still here, but thank you so much. That was goated. I was here for the last 10, 15 minutes at least. Love everything that's happening over there and amazing presentation as always. But how are you? How's the audience? Yeah.
Well, it's been like so amazing. I just love David. Like the guy is so smart. He's so down into these um, Predicate NFT packet driven development. Like it's so funny always to just spend some time talking about predicates and all of the
Mhm.
possibilities you can um, do with this technology. Um, David the Goal says Ruben. I think that indeed. Um, but building stuff requires to learn how to build stuff. Like there's the
Mhm.
problem of solving problems, and there's the problem of how to solve problems, how to use a technology, how to learn Web3. Hardik, tell
Absolutely.
us about Learn Web3.
Absolutely. So, for those of you who don't know, I'm one of the founders at Learn Web3. We basically do developer education. We have been doing developer education for the last two plus years now. And it's all designed as a public good. It's all free, it's all self-paced. You never pay us for anything. Um, so I want to come on here for two reasons. Number one, uh, we have a fuel course that is kind of in progress. It's a full stack fuel course. So we do everything from, what is fuel, day one, like what is fuel, all the way up until some of the cool things that David was even talking about in predicates. Like we have like we're building quote unquote like account abstracted wallet, smart wallets that can, transact on behalf of people. You can have like cool features like social recovery or multi-sigs or whatever it might be. So it goes all the way in the course. So we're building a course, and as we've been building that course, I've had a lot of experience with building on Fuel in general, like from normal contracts with scripts, predicates, and everything. So um, it's been an amazing experience. The Fuel team has been very, very helpful around everything related to that. So yeah, just wanted to mention that. Uh, I'm looking in the chat, but thank you. Um, just wanted to mention that, and if anybody over here in the audience is basically, interested in learning how to build on Fuel, maybe you're a Web 2 dev transitioning to Web 3, or you're in Web 3 but don't know much about how to build on Fuel. The Fuel course doesn't really assume a lot of background knowledge as long as you can understand like basic code. You don't have to know Rust, you don't have to know Sway. Um, you know, we're just assume that you can write some code. Oh, that is a UI bug I need to fix. But yeah, like given that, you should be able to go through the course. And as always, if you have any questions, we're more than happy to help you anytime.
Well, we're always shipping, like this is building in public almost. Um, okay. This is a challenge. We're not doing that, man. Stop being so hardcore, please. Let's pick the book on the stream now. We are not doing that. Thanks. Um, Hardik, um, like it's so amazing to just have like this place to fully learn like so fast, so quick, so easily. um but when I go on Twitter and try to find learn web3, I find the word DAO. What's going on? Like, how is that learn web3 it's a DAO?
That's actually a very interesting point. So it's kind of something that has stuck with us. This is honestly, we wanted to change it. Like Twitter is actually the only place that's left over. It is a sort of old leftover from early days that we eventually, when we first started, we were like, okay, we're gonna do community owned, and then over time we were like, doing that, having like proposals or whatever, like some sort of token might not be, the best for the kind of project we're building. We don't want to have a token make it seem unreasonable, whatever, like what is an education token. So we didn't end up eventually doing that. We kind of changed that name in most places, but Twitter was like, um, Twitter algorithm gets hurt pretty badly if you change it at the time. So it's a remnant of the past, but um, yeah, everywhere else it doesn't mention that anymore. Sorry about the
Well,
confusion.
yeah. Shadow banning is a real stuff, so please be careful with your naming, guys. Not talking specifically about Learn Web3, but everyone in the audience. But yeah, that's true in the Web3 space. Like we evolve so much on the time. I think it's a great moment to talk about history. So please let us know a little bit about you, like how you got into Web3, like what are you doing, how you got so excited about helping people to learn about this new technology.
Absolutely. So my personal background is like before Learn Web3, I was a protocol engineer. So I'd be doing like core L1, L2 level stuff, engineering wise mostly. And my sort of reason for how this kind of started, Learn Web3 when we first started was never meant to be a company. It was a project that happened to get a lot of users. So essentially what was happening was, when I first started coding, I'm from India. Um, I did everything online. There were thousands of free coding resources online when I was just first starting out, and I was forever thankful to them. So long story short, what happened was like 2021, late 2021, a friend of mine who I'd known for a few years, who worked at Google at the time, he wanted to get into Web3. So he was asking me, like, what are some places to get started? Where do I start learning? And around that time, like I didn't have like up to date idea on like beginner friendly resources, but I tried Googling a bit, tried searching around for a bit, and I didn't find anything I was super happy with at the time. And this is like we're talking about like Ethereum at the time, right? And I wasn't like super happy with the beginner resources at the time, so um, it was like I spent like a couple weeks, wrote some things myself, and then sort of like put it on like the first website Learn Web3 ever had. It was a very horrible website, very old days, but just sort of put together. It was kind of like a blog, I guess. I wrote like a few little blog posts, put it up there, and just added like Connect Wallet to it. And anyway, I sent it to him, posted about it on Twitter, etc. And within like the first sort of 6 weeks or something, we had like 20,000 people going through it, and we had like I don't know, like 8,000 people on the Discord, and they were like, "Okay, we want more complex stuff." And over time, like we just kept adding stuff to it, and then there was just a point where I was like, I'm spending more time doing this than my day job at the time. So quit the day job, started doing this full time, and the rest is history.
Well, it seems like another successful history of somebody getting into Web3 and just realizing that they can pursue their dreams. So I'm really glad for you for that. Um, you might ask, like, what's Community Peel? What's going on here? Fuel does has a grantee program, a really good grantee program, and we want builder to encourage to build on field, help the field ecosystem to growth. So if you are like Hardik and you want to pursue your dreams and just love in just work in whatever you love, come and say hi. Keep in touch. Maybe you have that predicate prediction market, and that's a fit for us. Hardik, please tell me how you got hype about Fuel, like how you got in touch, like what's the feature you like the most?
Absolutely. I think um, when did I first hear about Fuel? I don't even remember. It was just, you see stuff popping up on social media, you see people at events at hackathons. So I don't remember exactly when I first came across Fuel, but I remember being interested in it because of the, this was back when, like the modular centric future, and it was being portrayed as sort of that modular execution layer, which is a little bit changing. But at the time, that was what I came across, and I don't know. I was just looking into all the whole different modular stacks. I was researching into Fuel related projects at the time, like Celestia and whatnot, and I found it quite interesting. Noticed there was a sort of grants program open, so we'd love to work together to make a course on this. We got into the community grants, and since then, we've been in touch with David, in touch with Ruby, Harry, Wayne, absolutely amazing people, and very helpful. It's like the last sort of couple of months or so that we've been working on this. So very responsive in terms of helping us out, fixing any issues that we might come across, and um, apart from like core tech stuff, like just in general, just just the communication with the team has been impressive. And this is not sponsored, this is not scripted. I'm very genuine right now. But no, yeah, like that's how it is. And I think like we still have work to do. But yeah, it's been amazing ever since.
Well, I'm glad you liked my teammates. I like them too. And yeah, that's true. Regarding our Fuel Grantee program, we have a whole team of support for you, so you can like build with complete confidence. Learn Web3, like I just clicked on start learning and I just got into level up. Like this is a fully gamified experience. I can see a lot of stuff happening, like all of the basics you can share with a normie before getting into this Web3 messy buzzword space. So it looks so amazing. This is like more than 30K people went through this lecture. So it's like kudos on you and your team, Harik, because you are absolutely killing it. We have Dark as well, which I really appreciate because I think like this is not my actual setup. This is not my room. I'm moving to another home, but I keep my place dark all the time. So this is a really nice detail of care. Um, we are almost close to wrapping it up. Um, is there something else you would like to share with our people?
I think, yeah, I think like just the time I've spent building on Fuel, I think like this talk in particular, why I was super interested in joining it is just because I feel like predicates are amazing. The first time David explained to me how predicates work, we were on a like little 10-minute quick call. He explained it to me. I was like, it sounds almost too good to be true. And yes, it is early. There's, some limitations. There's still work to do, but um, overall, just the fact that predicates can be designed the way they are, it is amazing. As I said, like we have within the course, at later stages in the course, we're literally building, full on like smart wallets for users, like through a predicate. It's kind of like account abstraction on Ethereum, but happening through a predicate. And then you can do all sorts of fancy, like multi-sig stuff, or like, custom signatures or whatever. So you get the benefit of all of that in a sort of much cleaner, significantly less complicated. Like 4337 on mainnet is there's so many parties involved and so many things you need to understand if you want to go out and build an AA wallet. Where predicates, the way they work is just ingenious, honestly. Um, I'm very, very happy, by the way, if anyone in the audience wants to nerd out, if you're just starting out building predicates or getting started building on Fuel, like ping me in the Discord, and super happy to nerd out about all of this. But yeah, I think it's just like it's one of those things where like, until you really start looking into it, it's kind of like, okay, cool, it's like new thing, and then you look into it and it's like, holy shit, it's actually crazy.
Well, you can see how easy it is to get feel built and get hyped by this new stack of technology. Um, Looks like David is doing a great job just hyping up people regarding predicates. So thank you so much on that, David. Um, Beyond that, it's been a lovely experience sharing this small space with you, Hardik. Thank
Absolutely.
you so much for building Fuel. Thank you so much for being part of this amazing community. And thank you to, oh, look at this predicate build
100%. David killed.
100%. Yeah, so that's it. Thank you so much, Hardik.
Perfect.
Thanks for
Thank
joining
you
us
guys.
today.
Have a good day, good night, wherever you are. And thank you once again for having me. Cheers.
And well, this has been a lovely ride with you guys. Another week of amazing content happening right here, live streaming on Fuel Labs channels. Let's meet again next week. As I told you, we are doing an ETH Denver special. We will have agents in place letting us know what's going on Denver. For those of you who are missing ETH Denver, me as well, or I'm going to miss ETH Denver, but we will be here online taking a look on what's going on there. So thank you as well, Kev. And well, this is it. Thank you so much for joining us today. See you next week, same time, same channel. Um, and yeah, that's it. Thank you.